Yes. Now we are going to discuss the important, very important theorem, or the necessary and sufficient condition for Riemann integrability of a function. ఇది అసలు మెయిన్ థియరం. దీన్ని ప్రూవ్ చేయడం కోసం మనం లాస్ట్ ఫండమెంటల్స్ అండ్ డార్బాక్సీ థియరం వరకు ప్రూవ్ చేసుకున్నాం. ఓకే, ఆ ఫండమెంటల్స్ ఉన్న వీడియో అలాగే డార్బాక్సీ థియరం వీడియో చూడండి. అది చూస్తే మనం ఇది చేయొచ్చు. ఓకే, రైట్. ఇప్పుడు మనం ఈ థియరం ప్రూవ్ చేయడానికి డార్బాక్స్ థియరం వాడుకుంటాం. రైట్. అయితే అది చేసే ముందు ఫస్ట్ వాట్ ఈస్ ద స్టేట్మెంట్? సీరియస్. యాజ్ యూజువల్, if you want to discuss Riemann integrability, you want a bounded function. A bounded function f from a b to r is Riemann integrable. అంటే ఇది Riemann integrable అవ్వాలి అంటే on a b, if and only if for every epsilon greater than 0 there exists a partition such that UPF minus LPF is very small, that is less than epsilon. ఓకే, సో అంటే f Riemann integrable అయితే ఇలాంటి పార్టీషన్ కూడా దొరుకుతుంది. ఎలాంటి పార్టీషన్? యూపీఎఫ్ కి ఎల్పిఎఫ్ కి మధ్య డిఫరెన్స్ చాలా తక్కువ, వెరీ స్మాల్, అంటే ఆల్మోస్ట్ సేమ్ అని. ఓకే, అలా అయ్యేలాగా ఒక పార్టీషన్ దొరుకుతుంది. ఓకే, ఒకవేళ పార్టీషన్ దొరికితే ఎఫ్ ఇస్ రీమాన్ ఇంటిగ్రబుల్. దట్ ఈస్ వాట్ ద థియరం సేస్. ఓకే, ఫస్ట్ వి ప్రూవ్ ద ఇఫ్ పార్ట్ ఆర్ నెసెసరీ పార్ట్. ఓకే, ప్రూఫ్ ఆఫ్ ద థియరం. అండ్ నౌ ఓకే, ఫస్ట్ రైట్ ద hypothesis. Okay, exam lo మిమ్మల్ని state and prove necessary and sufficient condition for Riemann integrability of a function or Riemann integrability of a bounded function f on closed interval ab అని అడగొచ్చు. అప్పుడు మీరే ఈ స్టేట్మెంట్ రాసి ప్రూఫ్ మీరే రాయాలి. ఓకే, కాబట్టి యూ హ్యావ్ టు బై హార్ట్ దిస్ స్టేట్మెంట్ ఆల్సో. ఓకే, అపార్ట్ ఫ్రమ్ ద ప్రూఫ్ ఆఫ్ ద థియరం. ఓకే, వాట్ ఈస్ f? Suppose f from closed interval ab to r is a bounded function. Is a bounded function. Okay, this is what hypothesis. Now, first in necessary part or if part. What is necessary part? Okay, suppose f is Riemann integrable. ఓకే, ఇఫ్ అండ్ ఓన్లీ ఇఫ్ ముందు ఉన్నది అంటే రీమాన్ ఇంటిగ్రబుల్ అనుకుని ఈ కండిషన్ ప్రూవ్ చేయాలి, ఈ కండిషన్ అనుకుని రీమాన్ ఇంటిగ్రబుల్ ప్రూవ్ చేయాలి. ఓకే, ఫస్ట్ మనం ఏమి అస్యూమ్ చేసుకుంటామంటే సపోజ్ f is Riemann integrable. What is it? Riemann integrable on closed AB. దేని మీద? క్లోజ్డ్ ఇంటర్వల్ AB మీద ఇది Riemann integrable. Riemann integrable definition ఏంటి? This implies lower Riemann integral f of x dx is equal to upper Riemann integral f of x dx is same, and that equal value is nothing but integral a to b f of x dx. This is the definition of Riemann integration, right? Now ఇప్పుడు మనం ఇది చెప్పాలి ఏంటి? ఫర్ ఈచ్ ఎప్సిలాన్ గ్రేటర్ దెన్ 0 ఒక పార్టీషన్ ఎగ్జిస్ట్ అవుతుందని చెప్పాలి కదా. సో ఒక ఎప్సిలాన్ తీసుకోండి, లెట్ ఎప్సిలాన్ గ్రేటర్ దెన్ 0. ఈ ఎప్సిలాన్ కి మనం ఒక పార్టీషన్ వెతకాలి. ఇప్పుడు బై డార్బాక్సీ థియరం, బై డార్బాక్సిస్ థియరం. ఓకే, బై డార్బాక్సిస్ థియరం. ఓకే, ఫర్ దిస్ ఎప్సిలాన్ గ్రేటర్ దెన్ 0, ఓకే, దేర్ ఎగ్జిస్ట్ ఏ పార్టీషన్. Okay, by Darbox's theorem, there exists delta greater than 0 such that, okay, so first two conditions, the two conditions of the Darbox's theorem. What is it? Such that UPF, okay, UPF is less than integral a to b, that is upper Riemann integral. Okay, this is upper Riemann integral a to b f of x dx plus epsilon, and say this is 1, this is 2, and LPF is greater than lower Riemann integral a to b f of x dx plus, okay, instead of epsilon I take epsilon by 2, okay, because epsilon greater than 0 means epsilon by 2 is also greater than 0, right? So this is 3. Okay, where what is p? Where p belongs to phi of AB. I already told you so many times, phi of AB means p is a partition of AB with, what is the condition? Norm p is less than delta. Okay, this is just Darboux theorem statement. Okay, now we shall use it. Right. Now what we have to prove? 0 less than or equal to UPF minus LPF less than epsilon. Now from 2, okay, I'll do one thing. Okay, from 2 UPF is less than upper integral, see, write upper integral a to b bar, okay, f of x dx plus epsilon by 2. And but upper Riemann integral and lower Riemann integral is same as Riemann integration between a to b of f of x, Riemann integration of f of x dx from 1. Okay, upper Riemann integral I can remove it and write only Riemann integration of a to b f of x dx, Riemann integral, okay, plus epsilon by 2. Okay, and this is say 4. Okay, similarly, what is LPF? Okay, from 3, LPF is greater than, okay, integral lower integral a to b f of x dx minus, okay, here this is minus actually, okay, I wrote wrong, okay, this is minus epsilon by 2, okay, see the Darboux theorem also, that is minus epsilon, here in place of epsilon we are using epsilon by 2, so minus epsilon by 2, okay, this is given by 3 by Darboux theorem, and this implies minus LPF is less than minus lower integral f of x dx plus epsilon by 2, and this is equal to, okay, this is minus lower integral, okay, but f is, because from 1, because f is Riemann integrable, lower Riemann integral or upper Riemann integral both are same and equal to Riemann integration of f of x. So therefore this can be written as AB2 integral a to b f of x dx plus epsilon, and name it as phi. And we know that, okay, I'll erase it, okay, so we know that always we have, okay, for any partition P of AB, okay, we always have ఎప్పుడు కూడా upper Riemann sum is more than lower Riemann sum, or UPF is always more than or equal to or greater than or equal to LPF. Okay, or this implies, okay, this minus this is always greater than or equal to 0, is greater than or equal to 0, or I start like this. Therefore 0 less than or equal to UPF minus LPF. Okay, now from 4 I can write this is less than, okay, integral a to b f of x dx plus epsilon by 2. right? And this is from 5 minus LPF. See here, I forgot minus. Okay, from 5 I can write this as minus integral a to b f of x dx plus epsilon bit. Okay, see here, just I have used this 4 and 5. UPF is less than this and minus LPF is less than this. Okay, this implies 0 less than or equal to UPF minus LPF is less than, so this and this got cancelled, plus epsilon by 2 and plus epsilon by 2, that is epsilon. This is what we want to prove in the first part or necessary part. Okay, 0 less than or equal to UPF minus LPF less than epsilon. There exists a partition P like this. Okay, so this is very easy provided you already know the Darboux theorem. So here we have used Darboux theorem, right? Now we will prove the sufficient part. What is the sufficient part? Now we assume, okay, for every or for each epsilon greater than 0, we can find a partition P of AB, okay, which satisfies this condition. That is 0 less than or equal to upper Riemann sum minus lower Riemann sum is less than epsilon. Okay, that is the difference between upper Riemann sum and lower Riemann sum is very small. Okay, if this condition is satisfied, what we have to prove? Our claim is F is Riemann integrable. What do you have to prove? F is Riemann integrable. That is, what we prove is upper Riemann sum and lower Riemann sum of f of x are same. So to prove that f is Riemann integrable, what we have to prove is upper Riemann sum and lower Riemann sum are same. Okay. Now this is very easy part. Okay. So again we take the definitions of upper Riemann sum and lower Riemann sum. Okay. Okay. So the proof of the sufficient part we shall start like this. By definition. Okay. What is upper Riemann integral? A to b f of x dx is nothing but, okay, infimum, right? Infimum of what? All upper Riemann sums where P is any partition of AB. What do you mean by infimum? Greatest lower bound. So this implies integral a to b f of x dx is always, infimum means greatest lower bound, and this is also a lower bound. So less than or equal to UPF for any partition. Okay, for any P belongs to phi of A. That means P is any partition of AB, then this upper Riemann sum is lower bound of all the upper Riemann sums. So that is, every upper Riemann sum is more than this, or this is smaller than every upper Riemann sum. Similarly, what we have is, by definition, okay, what is the definition of lower Riemann sum? Lower Riemann integral. This is nothing but supremum or biggest of all LPFs, okay, where again P is any partition. Okay. Then supremum means least upper bound. Least upper bound means it is a upper bound first. So upper bound means this lower integral is more than every lower Riemann sum. This implies f of x dx is greater than or equal to every LPF, or I write like this. Okay, LPF. Okay, for all these LPFs, this is upper bound. What is upper bound? A to b f of x dx. Okay, for any partition, for any P belongs to phi of A. If I multiply with minus, f of x dx is less than or equal to LPF. That means this inequality got reversed, or you write LPF there and integration this side. Okay, for any partition P belongs to phi of A. Okay, and now we know that, okay, we have, okay, always the upper Riemann or lower Riemann integral is always smaller than upper Riemann integral. Lower Riemann integral, this is always smaller than this. This is already given to you, okay, in the fundamentals video. You please refer it. Okay, right. This is what we are going to use now. Now, this implies, okay, upper Riemann integral is more and lower Riemann integral is small. So, big number minus small number. Okay, upper Riemann integration minus lower Riemann integration. Okay, integral is always greater than or equal to 0. So we write like this: 0 less than or equal to upper Riemann integral a to b f of x dx, okay, minus lower Riemann integral f of x dx. Okay, and this is, see here, yes, here, say this is 1 and this is something like 2. Okay, from 1, this is less than or equal to UPF, and from 2, minus a to b, that is lower integral a to b f of x dx is less than or equal to minus LPF. I'm sorry, here I need minus, okay, minus LPF. Okay, and by this condition, what do we have? For any epsilon greater than 0, okay, there is a partition UPF minus LPF is less than epsilon. Okay, this is less than epsilon. Therefore, what we got is 0 less than or equal to UPF minus LPF is less than epsilon. Oh, I'm sorry. This implies, okay, what I got is, this implies 0 less than or equal to a to b f of x dx, that is upper Riemann integral minus lower Riemann integral is always less than epsilon. What is epsilon? For any epsilon, greater than 0. Okay, suppose epsilon is small, for example 0.0001, still this difference is small. Epsilon is 0.000 100 zeros 1, still this difference is small. Means what? Almost, not almost, they are equal. That is the only case. If they are equal, because epsilon is greater than 0, okay, positive. మీరు ఏ ఎప్సిలాన్ తీసుకున్నా ఆ వాల్యూ కంటే తక్కువ ఉండాలంటే ఏముండాలి? మీరు ఎప్సిలాన్ ఎంత 0.1000 zeros 1 తీసుకున్నా సరే దానికంటే తక్కువ. This implies this difference is 0. A to b f of x dx is equal to or minus f of x dx is equal to 0. This is upper Riemann integral, this is lower Riemann integral, the difference is 0. Or you can say that upper Riemann integration value is equal to lower Riemann integration value. So what is the definition of Riemann integration? If upper Riemann integration value and lower Riemann integration value are same, then therefore f is Riemann integrable on A. Okay, this is notation, right? This is same as writing f is Riemann integrable on A. Okay, this is the case when both upper Riemann sum and lower Riemann sum are same. Okay, this is the end of the theorem. This is very, very important theorem and almost compulsory. 95% or 99%. This is the compulsory question in the examination. Okay, so please take care.